This is SpaceTime, Series 21, Episode 57. Coming up on SpaceTime, what looks like another volcano discovered on the violent Jovian moon Io, a spectacular comet flaring with a frosty green glow, and the fastest ever launch to the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
As NASA's Juno spacecraft undertook its 13th close flyby of the gas giant Jupiter on Monday, earlier data appears to have turned up a new heat source near the south pole of Io, which could indicate a previously undiscovered volcano on the small Jovian moon. The new data was collected on December 16, 2017 by Juno's Jovian infrared auroral mapper GIRAM as the probe sped past about 470,000 kilometres from the moon. Past NASA probes, along with ground-based observatories, have so far located over 150 active volcanoes on Io. Scientists estimate there could be another 250 or so on the Galilean moon still waiting to be discovered. Juno co-investigator Alessandro Mura from the National Institute of Astrophysics in Rome says the new hotspot's only about 300 kilometres from the nearest previously mapped hotspot on Io. Scientists aren't ruling out the movement or modification of one of the previously discovered hotspots, but it's difficult to imagine how one hotspot could migrate over such a distance and still be considered the same feature. Mura says the Juno team will continue to evaluate data collected on the December 16 flyby, as well as new data to be collected during future even closer flybys of Io. Io is the most volcanic moon in the solar system. Whereas on Earth, or most places in the solar system, you'd get weather reports, on Io you'd get geothermal reports. There's new volcanic activity in the west and fresh lava lakes forming in the north. Io's volcanic activity is caused by friction, as the moon is constantly being squeezed and stretched by Jupiter's gravitational pull. Juno was launched on August 5, 2011 from the Cape Canaveral Air Force Station in Florida aboard an Atlas V rocket. The Lockheed Martin-built spacecraft is designed to study the chemical composition of Jupiter's immense atmosphere and cloud structure, peering deep below the obscuring cloud tops to probe the convection currents and thermal engines driving the planet's circulation patterns and spectacular surface weather features, cyclonic storms, and iconic salmon and cream-coloured atmospheric bands. Juno's also measuring Jupiter's gravitational field to better understand the internal structure of the solar system's largest planet, as well as its magnetic field, polar magnetosphere, and auroral activity. The probe is searching for a rocky Earth-sized core deep down in Jupiter's heart, and an exotic metallic hydrogen mantle surrounding it. Jupiter contains more mass than the rest of the solar system other than the Sun combined. So, by better understanding how the Jovian gas giant formed, scientists will learn more about the formation of the rest of the solar system as well. The 3,625 kilogram probe has now logged more than 235 million kilometres since achieving Jovian orbit insertion on July 5, 2016. The spacecraft was placed into a highly elongated polar orbit designed to avoid as much of Jupiter's damaging radiation belts as possible. This allows Juno to swoop down and skim just 3,400 kilometres above the swirling Jovian cloud tops before being taken back out to more than 8.1 million kilometres. To further protect the spacecraft from Jupiter's deadly radiation, Juno's most delicate instruments and control systems are housed in a specially shielded strongbox. NASA's original plans called for a total of 37 orbits around the 143,000 kilometre wide planet, with the original 53.4 Earth day polar orbits eventually contracting down to just 14 Earth days each. However, those plans were scrapped following concerns about the spacecraft's main engine, meaning that all orbits will now remain at 53.4 Earth days, which would have meant fewer overall orbits within the allotted time. The good news is that Juno appears to have coped with Jupiter's extreme radiation belts better than expected, allowing the mission to be extended. And by extending the mission, those missing orbits are now being included. You're listening to SpaceTime. I'm Stuart Gary. Comet PANSTARRS C 2017 S3 is generating more than the usual amount of excitement among skywatchers after suddenly flaring in brightness, generating a spectacular frosty green glow. The brilliant 16-fold increase in luminosity is making the comet's nucleus look twice the size of Jupiter. And C 2017 S3 is now generating a 260,000 kilometre wide stunning green tail. The sudden flarings most likely being caused by volatile frozen material buried deep inside the comet heating up and erupting through the crust into the empty vacuum of space. The comet's dive from high above the ecliptic, the average plane of the planets as they orbit around the Sun, suggests that C 2017 S3 may be a first-time visitor to the inner solar system from the distant Oort cloud, a theoretical sphere of comets, frozen worlds and icy debris extending from around 300 billion kilometres to over a light year from the Sun, deep into interstellar space. The Oort cloud contains objects either created early in the solar system's history or which originated from beyond the solar system and which have become gravitationally bound to the Sun. For our listeners in the Northern Hemisphere, C 2017 S3 is already easy to spot with a decent backyard telescope, and that's raising hopes that it may even become visible in daytime skies as it gets closer to the Sun. And if it survives its close encounter with the Sun, listeners south of the equator should be able to see it as a naked-eye comet after it swings around the Sun around the middle of August, with probably the best viewing shortly before sunrise on August the 15th. I'm Stuart Gary. This is SpaceTime. Okay, let's take a break from our show and talk about our sponsor, the Great Courses Plus. And the reason I'm so wrapped in this product is because my learning didn't end when I finished school or when I left university. There's still so much out there so much out there I need to learn. And that's where the Great Courses Plus comes in. And I think it's probably exactly the same for you. That's why you listen to this show in the first place. And that's also why I think you need to check out the Great Courses Plus. Because like me, I know you'll really enjoy watching and listening to these wonderful lectures, learning from some of the very best experts in their fields. And the Great Courses Plus gives you unlimited access to stream through, literally thousands and thousands of lectures, enjoying topics on science, history, business, art, what about music, even how to cook or take better photos. And the Great Courses Plus app lets you watch and listen whenever you like. This week I've been enjoying The Inescapable Universe by the great Dr. William deGrasse Tyson, famed astrophysicist and host of great programs like Cosmos and Star Talk. His course covers a lot of the topics we usually talk about on SpaceTime, things like neutrinos, quarks, dark matter, and the search for extraterrestrial life. In Part 2, The Spooky Universe, Neil covers Albert Einstein's general relativity theory, examining why time slows down the closer you accelerate towards the speed of light or the more massive an object is. In fact, this is the perfect course to get you started with the Great Courses Plus. And if science isn't your thing, that's okay too, because the Great Courses Plus offers more than 10,000 lectures on a really wide range of topics. And to get you started, we're offering a special free trial with unlimited access to the entire Great Courses Plus library. To start your free trial, just sign up through our special URL. Sign up at thegreatcoursesplus.com/space. That's thegreatcoursesplus.com/space, and that way they'll know you came from us, and so you'll be hoping to support our show. That's thegreatcoursesplus.com/space, and of course we will include the URL in the show notes. And now, it's back to our program. The Event Horizon Telescope is a project to image Sagittarius A star, the supermassive black hole at the centre of our Milky Way Galaxy. Sagittarius A star contains mass equivalent to 4.3 million times that of the Sun. But it's difficult to see, not just because it's located 26,000 light-years away at the western edge of the constellation Sagittarius, but also because from our point of view, it's shrouded by billions of stars and dense clouds of gas and dust. And that's where the Event Horizon Telescope comes in. It's a global network of radio telescopes combining data from several very long baseline interferometries around the Earth, synchronized to observe the immediate environment of the supermassive black hole. Astronomers are also using it to image an even larger black hole in the supergiant elliptical galaxy Messier 87, with an angular resolution comparable to the black hole's event horizon. Through very long baseline interferometry, many independent radio telescopes separated by hundreds of thousands of kilometres can be connected and used in concert to create a virtual telescope with an effective diameter of an entire planet. Each year since its first data capture in 2006, the Event Horizon Telescope has added additional observatories to its global network. The first ever direct image of the Milky Way supermassive black hole was expected to be produced back in April last year, but logistical problems have delayed the long-expected findings. See, the thing is, data from observations at each individual telescope is collected on hard drives and then transported by jetline from the various telescopes to MIT's Haystack Observatory in Massachusetts and the Max Planck Institute in Germany. There the data is time-matched, cross-correlated, and finally analysed on a grid computer made up of some 800 CPUs, all connected through a 40 gigabytes per second network. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson from the Australian Department of Science.
This galactic superstorm at the centre of our galaxy that we hope to be able to look at through an Earth-sized telescope, this sounds rather extraordinary.
It is, actually. And in fact, the looking has already been done. What's happening now is that the scientists who've done all that are working on the data to actually bring this clutch of radio telescopes, which is what they are, spread all over the Earth, to the signals from them to bring them into a kind of coherent picture of what their target is. And that's the superstorm, exactly as you've said. So backtracking a little bit, we know that at the center of our galaxy, and our galaxy, of course, this disk-like aggregation of hundreds of billions of stars, which we sort of see in cross-section as the Milky Way, towards the constellation of Sagittarius, that is where the center of the galaxy is. And astronomers have known for 30 years that there is a very bright radio source in the center of the galaxy. It rejoices in the name of Sagittarius A star, and that's why it's it's been known as ever since I've been an astronomer.
It's A star.
Yeah, well, A star, yeah. It's a capital A and an asterisk, actually, but it's usually called Sagittarius A star. And I think that distinguishes it from something else that was called Sagittarius A, which isn't the center of the galaxy.
Right.
So Sagittarius A star, a very bright radio source. We've looked in that direction with telescopes over many decades, including with infrared telescopes which penetrate the dust between ourselves and the galactic center and allow us to see stars orbiting around what looks like nothing, but this is in the infrared spectrum, but what they're actually orbiting around is a black hole. And we can use the way those stars orbit to measure the mass of the black hole. It's a big one. And it also has a swirling, what we call an accretion disk, a swirling disk of matter, which is the stuff that's being swallowed by the black hole. Now, black holes don't go around, voraciously looking for things to eat. But if stuff gets into their immediate neighborhood, yes, it spirals inwards and is devoured effectively by the black hole. And it's that spiraling that causes the radio waves and occasionally infrared bursts of radiation, and actually X-rays as well. So you get all these different radiations from the disk of material that's this maelstrom of stuff that is circulating around the black hole. The question is, that's fine. We've got really strong evidence that a black hole is there. It displays all the things we expect a black hole to show. Can we see it? So a few years ago, a whole bunch of radio astronomers got together and said, if we join up, and you can do this with radio telescopes much more easily than you can with visible light telescopes. With a radio telescope, you can kind of join them up together to form an array. And so what they suggested was a whole different bunch of telescopes. The ALMA telescope in the high Atacama, the JCMT, the James Clerk Maxwell telescope, which is in Hawaii. It's one that used to be run from Edinburgh, and I was very much involved with that 100 years ago. And other similar radio telescopes. You can link them all together to basically synthesize a telescope the diameter of the Earth. And that gives you the wherewithal to see things at very small angular scales. And by that, I mean, the angle with which you can actually spot detail. The detail they're looking for, and wait for this blows my mind. It's round about, the diameter of the thing that they're looking for is 37 micro arc seconds. So an arc second is 1/3600th of a degree. In fact, an arc second is the size of a dime in America, or a $1 coin here in Australia, or a pound coin in the UK, held up at a distance of 5 kilometres.
Oh, yes, yes, you've told me about that before. That just is unthinkable.
It's a tiny angle. That's 1 arc second. Now they're looking for 37 millionths of an arc second.
Oh my goodness.
Basically, it's a coin on the surface of the moon. That's what you're looking for. Very fine detail, and that's why you need all these telescopes linked together, which incidentally have a name.
I just read the name, but I'll let you say it. I just love this name. I know I'm often very critical about the way astronomers and space organisations name things, but this is a ripper.
I think it's a ripper too. It's the EHT, the Event Horizon Telescope. Actually, it could be extremely humongous telescope.
Well, we've done that one.
Yeah. Well, yeah. Anyway, the Event Horizon Telescope, it tells you what they're looking for. They're looking for this, I suppose phenomenon's the word for it, the event horizon. What is the event horizon? It's the let me put it this way, the sphere around a black hole. Okay.
The interface between a black hole and the universe as we know it.
That's right. The sphere around the black hole beyond which you can't see.
Yeah.
That's the definition of the event horizon. So the black hole's at the middle, but around it is this sphere of darkness, effectively, and it's dark because nothing can come out of it, and so stuff might go into it, but nothing can come out of it. That's this size of a coin on the surface of the moon is the size of the event horizon as seen from our vantage point here, 25,000 light years away from the center of our galaxy where this black hole is. So what they're doing with the EHT is basically looking at radio signals from the accretion disk, this swirling disk of material going round the event horizon. And they expect to see that, but silhouetted against it will be the event horizon itself. So there should be this sort of swirly mass of material with a black blob in the middle. And we also know from simulations that the curvature of space is very, very high near the event horizon. And by that I mean that, as we know, gravity distorts space. The gravity of the black hole is so extreme that the space around it is distorted in an extreme way. And you can actually see around the back of the event horizon, which is a bit weird. It's because the space is distorted so much. So there are simulations already of what
sort of like a fisheye lens to the extreme.
That's right, exactly like that. Yeah, it's sort of, a fisheye lens letting you see behind something that's stuck in the way, just because space is so heavily distorted. So all this is being fed into the models of what the astronomers expect to see. And I think the number crunching is going on as we speak. I don't know when the details will be released, but I hope that it won't be too far away. The EHT, just to give you a bit of detail, there's 9 radio telescopes. They're in Chile, the US, France, Spain, Mexico, and the Antarctic. So they're all over the world. And hopefully we might get some information about this soon. I think it's a very exciting thing to look forward to. The first time we've ever seen the event horizon of a black hole.
And that will be a significant moment in astronomy, because to date they are a theory because we haven't seen them. And exactly. Even though we know they exist, it's just... Yeah,
that's exactly right. This is big time stuff. As you say, it's a big milestone. Some people are suggesting that this is one of the big discoveries of the century, just like gravitational waves were. So, we're making these really huge steps in understanding how to observe the universe in very, very interesting and novel ways.
That's Dr. Fred Watson from the Department of Science speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Russia has set a new record, docking a Progress cargo ship to the International Space Station less than 4 hours after launch. The Progress MS-09 was launched aboard a Soyuz 2.1A rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan just 3 hours and 40 minutes and only 2.5 orbits before rendezvousing and docking with the orbiting outpost.
Turbo pumps up to flight speed. And liftoff. We have liftoff of the Progress resupply ship heading into the express lane bound for the International Space Station. Roll, pitch, and yaw program reported in good shape from the blockhouse down in Baikonur. Good vehicle stabilization.
Docking with a Russian Pirs module took place as both spacecraft were flying 410 kilometres over Australia at 27,592 kilometres per hour.
4 meters, standing by for contact and capture.
Copy, standing by for contact and capture confirmed.
Contact confirmed, capture confirmed.
Copy, contact and capture.
Docking confirmed at 8:31 p.m. Central Time, 9:31 p.m. Eastern Time, as Progress and the International Space Station flew 260 miles over the northern coast of Australia. A fast-track two-orbit rendezvous for Progress, setting another milestone in International Space Station history.
This was the third time the Russian Federal Space Agency at Roscosmos had attempted this ultra-fast track rendezvous. Previous attempts involving the Progress MS-07 and Progress MS-08 missions were cancelled after launch delays prevented the Soyuz launch trajectory from aligning precisely with the space station's ground track. In order to achieve this new ultra-fast track rendezvous, the space station needs to be orbiting southwest of Baikonur at the time of the launch, and tracking in a northeasterly direction on an alignment that will eventually place the Progress cargo ship directly in front of the orbiting outpost when Progress reaches the space station's orbital altitude 8 minutes and 45 seconds after launch. Previous fast rendezvous have involved 6.5-hour 4-orbit flights. That compares to the standard 2.5-day 36-orbit rendezvous flight plan. The Progress is carrying 2,567 kilograms of supplies for the orbiting outpost, including 530 kilograms of fuel, 52 kilograms of oxygen and air, 420 kilograms of fresh water, and 1,565 kilograms of food, personal items for the crew, and other supplies and equipment. You're listening to Space Time. I'm Stuart Gary. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has shown that people who regularly eat oranges are less likely to develop macular degeneration compared to those who don't consume oranges. Scientists from the Westmead Institute for Medical Research followed over 2,000 adults aged 50 and over for a 15-year period. The study found that people who ate at least one serving of oranges every day had a better than 60% reduced risk of developing late macular degeneration. Until now, most research has focused on the effects of common nutrients such as vitamin C, E, and A on the health of eyes. But the new research was different because it focused on the relationship between flavonoids and macular degeneration, showing that flavonoids in oranges appear to help prevent eye disease. Flavonoids are powerful antioxidants found in almost all fruits and vegetables, and they have important anti-inflammatory benefits for the immune system. Researchers examined common foods containing flavonoids, such as tea, apples, red wine, and oranges. 1 in 7 adults over the age of 50 have some signs of macular degeneration. In fact, age is the strongest known risk factor, and the disease is more likely to occur after the age of 50. There is currently no known cure. A new analysis of some 18 separate studies has concluded that taking multivitamins and mineral supplements does not prevent heart attacks, strokes, or cardiovascular death. The findings, reported in the American Heart Association's journal, put together the results from 18 individual published studies, including randomized control trials and prospective cohort studies, totaling more than 2 million participants and having an average of 12 years of follow-up. They found no association between taking multivitamins and mineral supplements and a lower risk of death from cardiovascular diseases. As many as 30% of Americans use multivitamin and mineral supplements, with the global nutritional supplement industry expected to be worth $278 billion by 2024. Well, just like greyhound racing, horse racing is an incredibly cruel pastime, the only purpose of which is gambling. Now a new study has found that the cruel practice of tying or strapping the tongues of racehorses to their lower jaws is extremely stressing to the animal. The findings, presented to the International Society for Equitation Sciences Conference, show that 1 in 5 racehorses in Australia have their tongues tied to their lower jaws. Horses who have their tongues tied show head tossing, backwards ear positioning, and gapping during tongue tying application, all behaviours that suggest increased stress for the animal. Tongue ties are used 6 times more often in Australia than they are in the UK, and the use of tongue ties has now been banned completely in Germany. Psychologists with the University of North Carolina have used a new technique to construct what a large sample of 511 American Christians think God looks like. Participants saw hundreds of randomly varying face pairs and selected which face from each pair appeared to be more like how they imagined God to look. By combining all the selected faces, researchers were able to assemble a composite face of God that reflected how each person imagined God to appear. Their results were both surprising and revealing. From Michelangelo to Monty Python, illustrations of the Judeo-Christian God have always shown him to be an old, august, white-bearded Caucasian man. But the new research suggests many Christians see God as younger, more feminine, and less Caucasian than popular culture suggests. In fact, people's perceptions of God tend to rely partly on their political affiliations. US liberals tended to see God as being more feminine, younger, and more loving than conservatives. On the other hand, American conservatives saw God as being more Caucasian and more powerful than liberals. People's perceptions also related to their own demographic characteristics. For example, younger people believe in a younger-looking God, and people who thought they were more physically attractive also believed in a more physically attractive-looking God. African Americans believed in a God that looked more African American than did Caucasians. So the basic finding was that people believe in a God who looks like them. Interestingly, however, people didn't show a bias on the basis of gender, with both male and female test subjects believing equally in a masculine-looking God. The scientific method involves observation, hypothesis, experimentation, analysis, and conclusion. Science is all about critical thinking. It's a search for the truth. Don't just take someone's word for it. Test the claim. See if it's factual and stands up to the scientific rigour. Or if, in reality, it's just a great steaming pile of woo. That's what skepticism and evidence-based science is all about. It's a search for the truth. And remember, scientific facts don't care if you like them or not. This week, we're looking at how the mainstream media covers fake science, trying to parade itself as real science. Balanced reporting only works if both sides are presenting facts of equal quality. When trained journalists allow one side to promote non-scientifically proven claims as fact, the very idea of balanced reporting is lost. For journalism to work, finding and reporting the truth requires both sides to stick to scientifically proven facts. Our report looks at how Australia's 7 television network has been promoting the work of an energy healer on their flagship Sunday night current affairs program. Now again, let me stress, our report is not about the energy healer's claims. I'm sure he honestly believes that what he does is real and that people are being helped as a result. But let's put all that to one side for a minute and look at a couple of important facts. Firstly, there is no peer-reviewed scientific evidence that energy healing works. This is not an opinion, it's a statement of fact. You can wheel out as many like-minded so-called experts and anecdotal claims as you want, but unless it's undergone proper scientific peer review processes, it's not scientific evidence. It's just a bunch of people who agree with you. And there's absolutely nothing wrong with that, but it's not science. Real science is about testing the claims in a manner which can be repeated and tested independently by others. There's a great saying in science, peer review or it never happened. Our report is about how Seven's flagship Sunday night program covered the story. Now, normally we would leave Media Watch to the experts, but when reporters cover science badly and we find out about it, well, let's face it, they're playing in our court. Aran Sergev, president of Australian Skeptics, watched the story as it unfolded.
The program started with claims and clips of people responding to being healed. So he was already kind of setting the scene in very dramatic fashion.
I think that's called priming the audience.
That's exactly what he was. The only thing mildly critical was done for effect. The journalist, Angela Cox, asked him if he was a con artist or crazy, and unsurprisingly said he was neither. The first case was a rather long case of somebody with severe neural pain disorder. It showed her claiming to be pain-free, and this is, again, several weeks later. I don't want to be...
placebo?
It could be. It could also be that she felt a little bit better because of placebo, but then went on to do things and simply more mobility and treating things differently, doing things differently.
Increase mobility,
but potentially. Yeah. Again, the thing is, I don't want to be unnecessarily dismissive. We were only shown a small proportion of what really happened, but I'm really glad she's feeling better. That's the most important thing.
Pain's a very subjective thing. We've spoken about this before, and there must be some special protocols one normally follows. I didn't see any of that in the show.
There are sophisticated protocols for assessing pain because it is known to be subjective, because it is known to respond very well to things that are outside of the actual physical aspect of the pain. So there are all kinds of instruments to allow us to measure pain, both in the short term and the long term, and none of these things were actually used. After we ended with this woman, there was a series of patients, this time with a skeptical doctor, Dr. Justin Coleman, observing. Dr. Coleman pointed out in advance of the examinations or the treatment that the underlying mechanism is so implausible that it would take a huge amount of evidence to convince him. So he was honest about not being easy to convince about this. But the test was really odd in that not only was it not blinded, all the patients were in the room at the same time. So in addition to the lack of blinding and the effects of, pain is a subjective matter,
so
the group effect.
Peer group pressure as well as placebo.
Absolutely. It's a group effect. It's a known thing where, one person is being helped. Everybody else wants to be helped. They don't want to be the ones who stand out. I'm not claiming anything about the pain. I'm not claiming the pain wasn't gone. I'm not claiming it is gone. What I'm claiming is that the situation was so unscientific that it is impossible to say either way. And that is the important thing.
Was it good journalism?
I think it was quite appalling journalism, actually, and I don't use this word lightly. Angela Cox works for a program supposed to represent investigative journalism.
We've seen this before, but haven't we, where what's supposed to be hard-nosed journalism eventually peters out and what's left are miracle cures. Magic water was a great one, which I think both the Current Affair and Today Tonight used to flog quite heavily, even though there's absolutely no scientific basis or truth for it.
No, absolutely.
What about the tactic of having the skeptic on first before you actually go into the full body of the story? Normally, wouldn't you only at the end bring the skeptic on to give his opinion of what he's seen?
Well, that's how you would do it if you wanted to do it properly. Now, again, in honesty, she did bring him on after, not just before, but also after.
Yeah, but he was kind of repeating what he'd already said.
He said he didn't see anything that would convince him because he felt that it was all within the realm of the kind of things that we know about pain. It was short. It was very brief, and considering the fact that the rest of the program was very much cheerleading, I think it was insufficient. The amount of time he was given is insufficient for him to properly explain why the evidence was not enough to convince him.
What should have been done? What should have the producers insisted? What should have the journalists conducting the interview done?
Okay, so let me just quote from Angela Cox herself. She wrote a piece about this, a promotional piece for news.com, where she said this: I have zero experience in medicine or science.
That's perfect journalist to cover a story.
Yeah. Now, that's the thing. I would expect a journalist to get proper advice when reporting on areas when they have no experience. And that clearly did not happen. She had no idea anything about blinding. She had no idea about pain. She was completely oblivious to even the basic things about this kind of test. So she worked for months, according to what they said, on a piece. And at the end of it, she was still able to say, I have zero experience in medicine or science. I'm sorry, that is not good enough. You would not put somebody like that on a piece about politics, for example, right? It's completely inappropriate. Science and medicine are complex issues. The impact of this kind of reporting can be serious. People might actually take the advice over the advice of their doctor and not seek appropriate advice. That is really dangerous. And it is irresponsible for somebody who says about herself that she has zero experience in medicine or science to be reporting on this clearly without getting appropriate advice, because the test was so completely inappropriate.
That's Iran Sergeyev, president of Australian Skeptics. The standard response to criticism about news organisations using general reporters to cover specialist stories is that tight budgets mean they simply don't have the luxury to employ specialist journalists. And believe me, I know that's true because I've heard exactly the same thing said when I was working for ABC News. And well, really, the answer is fairly simple. Don't cover those stories. To do otherwise sacrifices the integrity of the entire newsroom and the journalists working there, just so editors can say, oh, we covered that. All too often, we've seen so-called hard-hitting news and current affairs programs end up descending down the tabloid drain of magical cures or chasing soft targets that can't fight back. Open up in the name of the media. That's what the comedy series Frontline was all about. The trouble is, when journalism descends down this road, audience and credibility are always the losers. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.